From Chicago, welcome to 3Degrees Discussions. I'm your host, Mike Vasquez. This is a podcast devoted to the stories behind the innovators, entrepreneurs, and leaders in the 3D printing industry.
Xometry and in college, by the way, I was actually in product development, and I was both running a machine, but also we were sourcing a lot of parts, and so I've been both a buyer and a supplier. And one of the challenges has always been that sourcing side. Who do I look for? I get quotes in different places. So a lot of times you're waiting for these manual quotes to come back. I'm zipping up files in what you call a TDP, a technical data package. And it's a lot of waiting game. It's also, I'm only exposed to who I know, who I think can make these parts. Xometry's taken that in a different direction, kind of turned it on its head a little bit. So Xometry is a platform that's actually connected with over 5,000 capable manufacturers globally. And 3,000 of those are domestic in the US. And over time, we have been able to work and train machine learning AI to interpret a 3D model and provide pricing in over a dozen different manufacturing processes.
That was Greg Paulsen from Xometry. Greg leads Xometry's application engineering team. Xometry is an AI-driven manufacturing as a service marketplace platform. Greg started his career running polymer laser sintering systems and is now responsible for a number of different printing technologies within Xometry's portfolio. He joins the show to talk more about the company and his experiences being both a user and a customer of 3D printing, along with now being a supplier. All right, Greg, welcome to the show. Why don't we start with a little bit of background of how you got your start in additive manufacturing?
Hey, Mike, thank you so much for having me. I'm excited to talk about this, and certainly additive manufacturing has been a major part of my career in my life for a little over 13 years now. So it's been very exciting. I started in right around 2007 or so. And this was at James Madison University, where I was able and lucky enough to get my hands on selective laser sintering at that time, and ran SLS machine and learned that. And when I left college, I went to find a career focusing around that. So I ended up finding the only place in my area that actually had SLS, and I worked my way into running that center, and then ultimately found Xometry, a few years after that. And it's been really interesting because it's not just laser sintering. We're running DMLS metals, FDM, polyjet stereolithography, HP multijet fusion, carbon DLS, and I'm a kid in a candy shop now when it comes down to this because of our model of on-demand manufacturing, and we just have so many options.
So it's kind of rare that I talk to someone that got their start in SLS versus FDM. So kind of what did you take from kind of putting your hands in the powder, fiddling with parameters, I'm sure, and heating and all that with SLS that you've taken now to expand that into many different technologies?
I think it's very interesting. Yeah, to that point in 2007, when I was first learning, desktop FDM was not quite there. Rep machines were around $5,000. So I think the cupcake was a year or two off from the MakerBot platform, and that's really started the movement. So yeah, it is weird and it's backwards for sure. And I've been spoiled. I actually do not have a desktop FDM printer, although now I'm kind of craving one. Hashtag Christmas list. But yeah, I got into SLS, and at that time they were for rapid prototyping. So this is the machine that I was running. If we have any people that are in AM listening to this, it was a DTM Center Station 2500 Plus. Was the
very solid machine. I've run that one. It
is a beast. It's the thing about 2500 Plus is they're over-engineered. And even better, like half the parts you could get from McMaster car too. So like it's like in a shop where you have that car that you're always tinkering with. That's what these SLS machines were at that time. There's good and bad there. There's the good is that I didn't know the ins and outs of the machine. I knew how to take it out. If I saw something wrong, I could go back, find the timing belt, actually find the belt on McMaster that probably fits it, and fix some of these some of these pieces. Some of the things around the actual mechanics of moving the powder around were the proprietary part, but a lot of the structural stuff was part of what we call like this kind of Gen 1 or Gen 2 of additive machines, where there still was a lot of access. But that being said, a lot of that talent was in the operator's hands. I had to learn how to look at the powder, how to get a sense of what those first scans look like as a material. So SLS uses a laser to melt a nylon powder or polymer powder, but most of the time it's nylon. And you would actually look at inside the window. You look at the SLS TV and watch the first layers go down. And I was always looking for something that was kind of at this kind of crystally glistening snow look when the material was being scanned, because you didn't want it to look too glossy because you're over melting, and you didn't want it to look too matte, which means you're probably not really getting a good fusion on that Z direction. So you're probably going to have a more porous part. And there's a lot of tuning, which is absolutely great if I'm the engineer working on my engineering designs for my internal shop, and the parts that I'm using are for my purposes only. But I could tell you, a decade plus into this, when you're serving a customer, it's a very different story on how much I want to tinker with my production capabilities. And more modern machines have very highly vetted, tuned, parameter sets for that fusion process. Excuse me.
For sure. And now
And
you're, oh, go ahead.
oh, sorry, I just had a cough there, but yeah, it's let me restate that. So if we need to cut that out a little bit there, but the now we have machines that have a lot more of a feedback loop to them, that have finely tuned from the OEM machine running the OEM material with the OEM parameters. I will get X amount of quality assurance out of it, and it's very very good for serving a customer because I have a much higher, much more consistent result.
So can you tell us a little bit more about what Xometry is and how you got your start there?
Yeah, I'm always happy to. And Xometry, it's a really unique platform. So I always say it solves this problem of procurement. So I've been between Xometry and college. By the way, I was actually in product development, and I was both running a machine, but also we were sourcing a lot of parts. And so I've been both a buyer and a supplier. And one of the challenges has always been that sourcing side. Who do I look for? I get quotes in different places. So a lot of times you're waiting for these manual quotes to come back. I'm zipping up files in what you call a TDP, a technical data package. And it's a lot of waiting game. It's also, I'm only exposed to who I know, who I think can make these parts. Xometry's taken that in a different direction, kind of turned it on its head a little bit. So Xometry is a platform. It's actually connected with over 5,000 capable manufacturers globally, and 3,000 of those are domestic in the US. And over time, we have been able to work and train machine learning AI to interpret a 3D model and provide pricing in over a dozen different manufacturing processes. And that's the process itself. So the materials and the configurations like specs, finishes, tolerances, all that is just, all that also automatically updates. But the beauty of this is that we are able to actually allow a customer to upload a file and see pricing instantaneously, change their process, their materials, their configuration, the pricing updates, the lead time updates automatically, and they press go. And so this wait for the RFQ no longer is there. And then on the other side of that, we use data science, AI, machine learning also to matchmake. So Mike, if you ever watch Netflix and it gives you that recommendation score, like, hey, that's a 97% chance we think you're going to like this movie. There's some data science behind that. And we kind of do the same thing with this network of manufacturers. So based off the needs of that project, we actually pair with the manufacturers that are best able to do that work. So sometimes those are, straight configurations like ITAR to ITAR, for example. But sometimes it's about the work that from previous performance of those manufacturers that they've done to quality on time. And what allows us to do is have a secure, safe, and confident supply chain, regardless of the projects that are coming in, because we have so much access and so much parallel capacity through our vetted network.
So a lot of the kind of sticking with the additive manufacturing kind of theme. So I imagine a manufacturer that has a few SLS or MJF systems, they probably have their own business and may not rely fully on you. Like when they have excess capacity, that's when the matchmaking happens. Or is it, do you have suppliers that you're just sending parts to and they signed up to be in the Xometry network?
The vast majority of it, actually, I would say almost all the manufacturers are professional shops. So their business is to make parts professionally, to spec it on time. We could be 10% of the revenue, we could be 90% of the revenue. It just depends on the shop's size, capabilities, and kind of how they want to work within the mix. What we provide is a platform for those manufacturers to get work on demand. So they're seeing one work and they're not bidding against it. It's not a bid war. It's almost like a Uber. If you're an Uber or Lyft driver, you'll say like, "Hey, there's a fair in your area. We'll pay you this much, and do you want to take it? Yes or pass." And so for the manufacturers, they'll be able to take a look at the work, review the scope. Hopefully it's, like I said, with that match score, it's something that they would want to do in their work, and they could say yes. And as soon as they press yes, it's an instant purchase order. They don't need the market for it or anything. They get the work, and they're able to do, what they do best, which is just make parts. Or they could pass. So say their shop's at capacity or it's not the best fit, they could pass and it'll go to the next available manufacturer. So yeah, what's interesting is that though there is actually a difference, for example, from a machine supplier on our network and a service bureau. I think you hinted at that a little bit with, they may have multiple machines.
And as your role as an application engineer or kind of running that group, how do you kind of work with the incoming parts? So, I mean, since you have so many different platforms, 3D printing, non 3D printing, designed for each of those manufacturing processes, quite unique. And then you have this added layer of kind of getting as many parts out as you can and the supplier network. But how do you kind of help with upfront with designing of parts and saying, okay, this part's not going to do great, or the manufacturer has to think about this when they're producing the part?
Yeah, we definitely, I've helped create a lot of this. We definitely have resources online for design for manufacturability, design tips, and other guidelines. In fact, if you go to xometry.com site, so XOMETRY is how you spell it. So we have kind of an X at the front of our name. If you go into the resources tab, there's videos. We have written guides. We have our design guides that are downloadable guides on all these different manufacturing technologies, because no one knows a dozen manufacturing technologies back and forth. And it's really good to understand what the cues are for each tech and those nuances to help you design and manage your expectations about what you're going to get. I know we were talking a little bit before this chat about powder AM, right? So powder metal in particular. And I think when someone is thinking about metal 3D printing, their mind may immediately start thinking about these glossy, shiny parts that they may have seen in like an ad or in the front of a brochure somewhere. And there's a disconnect with what a regular metal print looks like versus one that's been, heavily post-processed, either post-machine or polished. And so even, for example, on our site, pictures can be worth literally 1,000 words, just to help manage what you're going to get out of this process and really where the strengths are. So why would I choose, for example, direct metal laser sintering over CNC machining for this project? And I think we have a lot of that on that pre-sale side to help manage those understandings. And then, of course, you have that instant pricing and feedback to help you make some business decisions. And even on the post-sale, we do have some design for manufacturability review to help, just in case there is something that we may have a recommendation for a different process for.
Do you see most of your customers, and I mean customers, kind of the folks that are submitting the actual CAD files, STL files to you, as using it particularly for prototyping, proof of concept, kind of pre-production, kind of vetting out design concepts?
So it's been really interesting. I'll focus on AM because we're talking about more traditional technologies. Although it's been the other way around where they're typically more production oriented, but now pricing and lead times have gotten much more competitive. So you can use rapid prototyping for machining or for sheet metal and even rapid injection molding. For AM, it's been a little bit different because there's not a strong design constraint for what these machines can do. You can take a lot of parts and throw them in there. Now, some parts can be better designed for the process, especially in a production setting, but typically they're more designed for giving. And so it's been the king for rapid prototyping. In 2 days, I could get a part in a durable end-use nylon that is the geometric shape of my 3D design. And that's really compelling for the rapid prototyping side. But as time has changed, I think especially, gosh, I started in Xometry uh, nearly 7 years ago, and at that time it was still mostly rapid prototyping and some talk of additive for production. And I've noticed more and more in with the mix of rapid prototypes, because additive is still king in that area. You see low volumes. You start seeing low or medium volumes, or repeat orders where these parts are being used for end use in a just-in-time manufacturing environment. And the designs have not been designed for injection mold or CNC. They've been designed for additive manufacturing, and they're using them as these end-use parts. And as we are right at the end of here when we're recording this at 2020, I'm seeing them more than ever, is that the design intent from the beginning of the process was for this part to ultimately be an additive, and it's becoming a larger percentage each year from a workflow.
And do you see particular industries that are leading the way on that?
Well, I think there's definitely is some advantage for IoT devices and other. I would say something like niche medical devices or devices that have a lower market or a smaller market, like some market in the thousands versus markets or thousands or tens of thousands versus market in the millions, where additive can play a role, especially with revision change. One of the things that we talk about with injection molding, we usually talk about tool life. So how long do you plan on running this tool? And typically the tool doesn't wear out, the revision wears out. And so additive has this unique ability to play a role where if you have, for example, if you have something that is holding a circuit board and the circuit board or component on it changes and you need to change your design, you're not shot a tool. In this case, you update your 3D model and you're able to use it again for direct digital manufacturing via additive. So I see that a lot. We're also seeing that in not in the direct production of items like aircraft and automotive, although there definitely is in aerospace, there's more of a role because of lightweighting. But I have seen a lot of factory level tooling assists using additive manufacturing for some of their free form, highly specialized design, where you may see again like low volume production units for assistance on the factory floor.
And you must have access to a lot of interesting customer data as you get repeat orders and kind of different types of parts for different manufacturing. Are there any trends that you've seen or you've kind of interpreted over the years? Do people start with FDM and go into powder SLS or MJF and then DMLS, or are there any preferences for machines or types of technologies that you've seen specifically on the additive side?
Well, it's interesting. So earlier on, when we were talking, you were saying it's surprising that I wasn't in FDM before I was in SLS. So I've always had that mentality about the powers of SLS and HP multi-jet fusion are both powder bed fusion technologies that have this amazing ability to output a lot of parts a night, because I can array parts and different parts, so that it's not just, I can make 300 of the same parts in one machine, but I can also make 10 of those and 12 other people's jobs in the same platform. Like array, it's both on an X and Y plane, so beside each other's neighbors, as well as above and between. So I can essentially float them in that virtual space. And what we find is, a lot of folks may come to Xometry with this idea that I want FDM because they may be prototyping in their own machines, which they may have a desktop FDM 3D printer. And sometimes when the production volumes get higher, a lot of times we may look at options using some of these powder bed fusion technologies, because we tend to have a higher throughput. So that's the amount of parts that I could ship per night, or the bulk parts I could ship per week out of those machines, versus FDM, which has much more of a serialized way of producing parts. It's kind of like FDM is, if you think about these old school 2D plotters that you put in the pen, and the pen would kind of draw all the lines and the numbers for you, very entertaining to watch. But also, if you're trying to make 300 of those, it's very time consuming, because you're essentially drawing a line at a time. And so if I have 20 parts on the FDM platform, per layer, I'm drawing that layer 20 times in a row without a lot of um, I would say, added benefit to it. Like other than the fact that I could just fit all those in my machine. But with MJF and SLS, my scan time per layer stays relatively consistent regardless of the density pack that I have in those machines. So within about 20, 30-hour period, I could just pack a machine and run through. And I think our average builds are 30 to 300 parts per machine per night.
And so when when thinking about production parts, especially in powder at that scale, how do you do the post processing? I guess, is there any efficiencies that you've gained through kind of scaling this out to a lot of different manufacturers? Are there best practices that sometimes you could share between your network, or is it really just independent kind of approaches
Oh,
to all these?
absolutely. We want to float all boats. I want to make the engineers that use us more educated on our additive manufacturing technologies. We want to make the folks that are running these machines as professional services, we want them to get more revenue. We want them to get more success. And I'm a true believer of, there's this book called The Goal, which is all about throughput. It's all about, how can you increase your revenue by getting your shippables up per day. And additive has this ability to do a lot of that parallel work for you. So just inherently in that is the ability to actually do a lot of shippables per day, because I'm not doing individual setups per part. I'm running one part at a time. I can do multiple parts at a time. I've actually written a guide on our partner blog about how to increase the efficiency of your additive production facility, which helps there. And one of the other things that we do at Xometry is we're only running professional additive manufacturing equipment. So this is industrial scale. So, it's not a $500 printer. It's not a $5,000 printer. A lot of times these printers are 50,000 to 500,000 and beyond, depending on the technology and class of machine that you're running. But one of the things that comes with that, to your point about post processing, is there's a lot more automation there. So, for example, my FDM is Stratasys Fortis FDM. A lot of my material is soluble, has soluble support structure. So it's not just a single material, there's two materials running at a time. I can actually take those parts out of the machine, and I can get them to essentially a sodium hydroxide bath, throw them in there, and the support structure dissolves away. So then I'm able to clear off those parts, dry them out, and get them shipped out the door. With these powder bed processes, they are usually kind of rough depowdered, so by hand, and then bead blast to clean, which is actually pretty quick to bead blast out those parts. And things like metal, carbon DLS, stereolithography, those do require manual support removals. In some cases, metal, sometimes it requires more machining to that. But again, these are production facilities where they have workflows in place to do that very, very well. So they're not surprised when they get a job. They're expecting to do full builds every single day.
And I'm assuming along those same lines, you have some level of quality control that goes through the process, at least for a baseline for these parts.
Yeah, absolutely. And that's one of the benefits of running industrial machines, is that the equipment, when you have the OEM materials or these more industrial materials that have been highly characterized, highly vetted out, so we have data sheets for them, they have parameter sets for them, and running on these machines, they run with a very high level of confidence, especially versus a desktop model. So the first part of that quality assurance is the type of machine and equipment that we choose to have as part of our network and to serve our customers with for that consistent experience and consistent lead times that we offer. So quick lead times, good parts. On the additive side for inspection, it is interesting because we talk about the rapid prototype versus a production component. There are designs that can grow on a machine, so designs that can be made in an additive platform, but may not be designed for that additive manufacturing platform. So we offer general tolerances that are typical for these manufacturing processes. But if you are rapid prototyping a design you just made, it's the first time in existence that that part ever showed up in a tangible reality, right? And depending on the process, you're going to have different tolerances and different outcomes based off the combination of that material, the processes running it, and the part geometry, which is something that the engineer designer controls. So we have processes that give you those typical outcomes. If you're tuning for a tighter tolerance or some sort of fit, sometimes you do need to iterate through. This is where I'll go back to the design guide and say your iterations will be significantly cut down if you read through design guides to understand the process and the materials up front, because there may be nuances like offset this internal hole by 0.006 of an inch in order to make these parts fit, or understand that this type of clearance of a thin gap may not be able to be fully cleared of material, so open up the gap to X amount, and all that stuff is part of understanding the process.
Is it also sometimes on the manufacturer as well? Because I mean, I could imagine a part situation where I'm in tolerance with the design guide, but you farm it out to 4 or 5 different surface bureaus, and you could get back 4 different geometry orientations in the build based on how much they're packing, and even certainly SLS or MJF, like that may have implications on that as well. Do you ever get kind of in that level of detail with customers, or does it mainly stay to?
Well, I'll say definitely with each one of our manufacturers, these are vetted partners. They have quality control systems in place, and we also have our Xometry quality program that they're adhering to as well. If we do run into any of those issues, so say there's an RMA or NCMR, Xometry itself, we are ISO 9001 and AS 9100. And we take quality extremely seriously. So we do go back, review those, get those parts back, and work to understand what the root cause is, and do a remake of those parts typically, if that's the case. But usually, when it comes to orientation, there are best practices that you'll see are very consistent amongst different providers, especially because a lot of the equipment they're running is the same type of equipment. And part to part, we do have a workflow embedded in our machine learned matchmaking system that will connect a reorder of the same part or a revision of that part with the original manufacturer within our manufacturing network. So you do get a consistent experience from order to order with the parts that you're ordering.
Got it. And kind of flipping back and forth between kind of your manufacturing network and your customers, kind of when, and I've used Xometry, I've used others, kind of similar platforms as well. Kind of what do you think is kind of the main reason that people are drawn to your platform? I know from my experience, it's pretty easy user interface, especially if you know the technologies. Generally, you guys have very good pricing as well compared to others, like and some of these other networks are growing as well. There's Proto Labs is a very big network of manufacturers. I think there's been some acquisitions and other service bureaus. So kind of what sets you guys apart when folks are coming to kind of your
Yeah.
site and looking to work with you?
Well, I think you really mentioned pricing and lead time is a very big deal, and with this distributed manufacturing network, uh, I think I'm gonna mess this up a little bit. I was talking with my COO the other day, but what happens when a marketplace is rich with supply, right? Pricing goes down, and we're able to provide competitive pricing and quick lead times because we have a large marketplace that's able to perform the manufacturing of those parts. And again, it's not just for AM; it's for machining and other processes as well as quick lead times because we're not bottlenecked. We're able to start that work immediately. The fact that we have so many manufacturing processes also makes it very convenient for our customers because they can order multiple technologies and multiple materials under those technologies all at one time. A great example of that is BMW. So BMW, who they're also an investor of ours, and they've been a customer since before they invested. Um, we see a lot of work coming through them through their tooling engineering side for their X line production plan, and their jigs and fixtures tend to be a mixture of additive components to kind of hug the curves to do those organic curves and contours, as well as additive has this benefit, especially they're running a lot of for the large body components FDM materials where you can actually give a sparse infill. So if they're a handheld component, it's lighter weight, but it's still very structural. But for rigid components, they'll use CNC machining, so Delrin and aluminum often. And for soft touch components, they'll actually use urethane casting. So a lot of times they'll be able to just put that all on one list and kind of like an Amazon shopping cart, just press order and get going with their day, and we take care of the rest of the service. Our production is very white glove, so you are dealing with Xometry. Xometry is your vendor. We are the quality assurance managers. We're the case managers for you. We take care of everything. So once you press order, we're taking care of that entire supply chain. And all you got to think about is my parts are coming Tuesday, and that's really what our goal there.
And when you think about kind of pricing, how do you see this playing out in kind of going forward? I mean, let's take kind of powder SLS for instance. I mean, from when you started, the price of nylon 12 from Evonik or any of the other one or two suppliers has remained the same, maybe a little bit lower for bulk. The printers are arguably about the same price, even some of the MGF. I mean, there's a little bit of speed gain, but as you kind of think about scale of the technology, what gets you like where does the rubber meet the road in terms of kind of how low of pricing can you go with some of the limits that you're put on by some of the industrial equipment and the business models that have kind of existed for a decade at this point?
Yeah, I think you have a really good observation. I think all of us in the industry have that exact same observation, which is these technologies are very, very good. Some of the material costs really have not gotten more competitive on that. So a lot of the pricing has to do with what you're able to scale. How many parts can I run in my machine per night? What am I like? What type of material can get cheaper with bulk discounting, which is very good. But I think there is going to be more pressure coming from this consumer prosumer market that is awesome, by the way, super awesome to watch. And as their quality, consistency, and competitiveness comes up, I mean, we're keeping an eye on that market because we're a distributor. We're not married to any particular technology. We just know what gives the best customer experience for price and lead time. And if technologies come into play where they can be competitive and awesome compared to kind of what's been legacy there, I definitely, as a distributed manufacturing platform, I would love to offer that to our client base. But again, for us, the biggest thing is, can I give my client a data sheet on that material? Can I give them a consistent experience with that? Can I give design guidance that will help with predictability of the outcome? And I think sometimes that's been a challenge. But absolutely, I think the more competitive the market is, hopefully the more the big players respond with some very, hopefully positive outcomes.
And we're getting to the end of the year, and outlook is hopefully a little bit better for 2021. Are there things you're excited about, new projects, new initiatives that you could share with the audience?
Yeah, I think so. We've been chugging along, and I think it's definitely been a very interesting year. There's been a lot of disruptions, and COVID-19 has affected, everybody. You've got both buyers and suppliers out there. Um, I'm glad to see, vaccines. Again, at this point of recording, vaccines are starting to show their way slowly but surely, uh, and there's, um, I'm really hoping for a brighter 2021. That being said, with our platform, I think Xometry's been able to take just a very, um, I would say, lead by example approach to these disruptions, because there's been forest fires in California, there's been tropical storms in Florida and Texas, and for our customers, we've had no domestic disruption of manufacturing in the last 10 months. And for our suppliers, we've been able to issue out essential business letters to keep our suppliers open and running as Xometry manufacturers, and we've been able to work with our suppliers on ways to help their cash flow keep on coming, even with disruption of their local market. The people that are usually buying from them, they've been able to get work through Xometry. So I think we've been very proud of the community that we've been able to build, and we're even more excited about what we're able to do with that. So in 2021, we are maturing what we call a digital RFQ marketplace, and that's an opportunity for customers to not just use Xometry for the instant quoting engine, but say there is a production or niche project that may not be an exact fit for what our quoting engine is able to do. They could actually go and directly connect with the suppliers at Xometry we've already vetted in our network, and create direct connect projects, and even get feedback directly from those manufacturers within our network. It's something we're really excited to be able to do, because we have all this capability. And we just want to make sure that our customers know that just because it's not in that drop-down box doesn't mean we can't do it. In fact, we do this type of work all the time. So beyond just custom, like, what else can we do for you? Contract manufacturing, other services, I think is something that's been very exciting and is on the horizon for us. I also want to say there's something that I'm so excited about, that our CEO has really championed this initiative. He's very mindful of the climate and global climate change. And for the last year, all our shipping domestic from Xometry we've actually been partnered with a company to offset the carbon emissions from the shipping. And we've been doing that for free. That's been just part of, if you order from Xometry in the last year, that's already been happening. But we actually just added on our quoting engine the ability for you to select and choose if you want to purchase carbon offsets for the manufacturing of your project. So you can actually go right now on Xometry's site. So go to xometry.com, click get a quote, upload a 3D model, select your process material, and you'll see what the carbon footprint for that manufacturing will be. And you could choose to offset a portion of it or all of it. And you can even choose where you want to offset that. So if it's building new forests, if it's wind energy, you could actually choose that right on the site as per your order. And I think that's just something that with this type of platform, it's one of the only mechanisms in which which we're able to do that. You couldn't do that with a traditional manufacturer. And it's just something really exciting to think about when you think about digital manufacturing and this industry 4.0.
Fantastic. Well, thank you so much for the time today. And this is a very insightful conversation, and look forward to staying in touch.
Awesome, Mike. Thank you so much. Yeah, it's always fun to talk about, and I love getting in the weeds with manufacturing and talking more shop for sure.
Great. Thank you so much.
All right, thanks, Mike.